Good morning, everybody. My name is Gary Russell. Those of you that were here last year, I took over from Mark Fisher to lead Spring Integration and Spring AMQP about 18 months ago now. So Mark could spend some more concentrated effort on the Spring XD project. I still work very closely with Mark. A lot has happened in the last 12 months since we were together last time. We've had two major releases, 3.0 and 4.0, and you might wonder, well, why do we have two major releases? Well, 3.0 was planned for some time and had a lot of content, but as part of the effort to put WebSocket support and Stomp into core Spring and Spring MVC, a lot of the core messaging infrastructure, message object, message builders and such, moved into the Spring messaging module within core Spring. So we felt that we needed to embrace that and to change Spring integration to use those core interfaces and classes, and we felt we had to make it another major release. So that was why we sort of bumped 3.0 and then 4.0. And 4.0, of course, requires Spring Framework 4 because it uses those objects from Spring messaging. We just on Friday released the 4.1 milestone, and we'll talk a little bit about that and what additional things that gives us briefly. And that too is going to require Spring Framework 4.1 because of some other infrastructure changes in core Spring. So what was in 3.0? One of the sort of underlying functionality that is not really exposed is the ability to detect and hardwire classes that are implementations of message handling. As I'm sure most of you who are active Spring integration users, we generally recommend coding with POJOs so that your application is not tied to the messaging framework. But when there are particular performance critical cases, then if we detect that a service active, for example, references an object that is a message handler, then we'll tightly wire that to the channel. We did a lot of work in SpEL. Those of you that have been around for a while will know that we had some inconsistencies with SpEL, where some cases you could reference beans, some cases you couldn't. So we did a major consolidation, and we have a shared application context, evaluation context, and now that enables anywhere within Spring integration that you can use SpEL, you get a known set of objects, and it also enabled us to support adding SpEL functions. So you can add your own functions to the environment and then reference them. You know, there I've said, pound foo, so you've got a function called foo that does anything you want. So again, that was enabled by the fact that we have this shared evaluation context that all the SpEL expressions use. And similarly, we added the ability to add custom property accesses. So if you've got some bean or some payload that doesn't fit the Java bean style and you need some special way to access the variables in that payload, then you can add your own property accessor. Header channel registry. This was anybody that's ever seen the no reply channel header and no output channel specified boom problem. This particularly is a case when we've got an inbound gateway that's expecting a reply. We put the reply channel in the header, and then somebody might put a JMS back channel in the flow, which would serialize that message to JMS. Obviously, the reply channel was a concrete or a live object, and there's no way you can serialize that. So we'd lose the reply channel. So then when it went down and the reply wanted to come back, we'd lose the reply, or we'd say we wouldn't be able to route the reply. So we have this header channel registry. You can now tell the framework to, I know I'm going to serialize this message, so register the reply channel with the registry before we do the serialization, and then when the the ultimate consumer of that message wants to send a reply, if there's no reply channel header, it consults the registry so that we can now do serialization of messages in a flow, so perhaps a longer lived flow or one that has persistent channels, and still use the request reply pattern. We added a couple of adapters, syslog and for tailing files. Content enricher, this was a feature that came from the community that was a desire that when we invoke a subflow to enrich a payload, you couldn't actually update headers at the same time. So this was we had a workaround on the wiki, but this was to consolidate that and say that if you call a downstream flow using an enricher, we can basically do anything we want to the message, including the headers. When you declare a gateway now, you can define a bunch of headers that will be set for all methods within that gateway. This was particularly interesting because now we can easily set the method object that's being invoked. So your flow downstream can now interrogate that header and say, okay, what was the original inbound method on the request that was called from the caller. HTTP, we sort of built on top of the work in Spring MVC for, we can now have multiple URLs for an endpoint. We added IDs to, or if you have a chain, you've got a bunch of elements within a chain, it was often difficult in a log, said such and such a endpoint received a message, you couldn't tell what it was. So now you can identify individual elements within the chain. Persistent file list filters, this is so that, as I'm sure you're all aware, if you're using a file inbound adapter, the default is the accept once file list filter, but it's an in-memory implementation, so it doesn't survive application restarts. You can now use persistent file list filters. The SFTP outbound gateway, or SFTP and FTP outbound gateways, you can now do mgets, you can do recursive listing of the remote directory. And there's a link there just to the what's new in the documentation. So then, earlier this year, we came along with Spring Integration 4.0, and as I said, that requires Spring Framework 4.0, and it does provide you, if you are doing WebSocket and Stomp development, you can directly interact with the Spring integration flow with the messages that come from there. So the Spring messaging message object is now fully compatible with Spring integration. Annotation-based configuration, that's going to be the main part of this talk. We're going to look at that with a demo, and there can be meta annotations, so you don't have to tie your code to the framework. You can use your own annotations and annotate them with our annotations so that we can detect such objects. We added MQTT channel adapters. We also added this distributed lock register. This was an interesting piece of technology, and one it helps with the persistent file list filters that I mentioned in the previous slide. So now if we have multiple instances of a file inbound channel adapter, one of the classic problems there is I want a cluster, I want to have multiple instances running, but they're all going to, and let's say they're looking at the same share, the same NFS share, then there's no way to stop one seeing it. You'll end up, two instances or two or more instances will see the same file. So with this global lock registry or distributed lock registry technique, and we provided at least for now, Redis and Gemfire implementations, together with this persistent file list filter, we can enable clustering of inbound channel adapters so they don't all use the same or see the same file. And that's actually together with the persistent metadata store, which also we have Redis and Gemfire implementations. Now, the lock registry is also interested in that anybody that's familiar with the aggregator, so we lock on the group ID. So when a message arrives at an aggregator, we lock on the group ID. we add the message to the group, look at the release strategy. Is it time to release this group? And if it is, then we release it. Again, that wouldn't work in a clustered environment. With the distributed lock registry now, you can have multiple instances of the aggregator, and they will they'll all cooperate, and the lock will be across the cluster. We added Twitter search, outbound gateway. And finally, the aggregator is now active. It used to be that if you wanted to time out a group, you had to configure a message group store reaper so that, you know, we're waiting for 10 messages, but only 8 showed up. We want to expire that group. You can still use a message group store reaper, or we now have this group timeout or group timeout expression on the aggregator, so it itself will expire the group when the time is exceeded. And again, a link to the what's new in the documentation. But the main thrust of 4.0 was consolidation with Spring messaging and a much improved annotation support. And that's, as I say, that's what we're going to be looking at later. We're also going to look in the demo at the Java DSL. This is probably one of the most asked for features. Still, there are people out there, believe it or not, who don't like XML. So we do have, and I think it's pretty powerful, and you'll see that in the demo, implementation of a domain-specific language for wiring up your Spring integration flow. It does work with JDK 6 and 7, but JDK 8 really, it blossoms in JDK 8 because we use lambdas, and it's a very succinct syntax, and hopefully you'll see that when we do the demo. We do have, we just released a milestone. One thing I want to make clear is the milestone release, obviously all the core enterprise integration patterns are supported by the DSL. We have support for file, FTP, SFTP, JMS, Rabbit, and now mail, and we will see that in the demo. When we release, so we're going to release it probably around the end of October, early November, when we release integration 4.1. But it probably won't have support for all of the adapters that we have in the framework. So, for those of you that are interested in the DSL and have a particular need, you know, I want the MQTT adapters, for example, to be DSL capable. Then please provide feedback, and we'll prioritize them based on the community need. But we definitely will release it, but it will be, as I said, a partial. We did release the milestone yesterday. The DSL reference is fairly, it's got a lot of good examples, and as I say, we'll see that in the demo. And so it's time to actually do that, to move to the demo. Now, did anybody watch my webinar in the spring? I did a webinar on sort of introducing the DSL and the annotation-based configuration. I guess not. Okay, so well, this is building on top of that. It's in the same project in the samples repo. It's not currently committed to master, but it'll be there within the next day or two. So with that, let's take a look. So I'm going to just break this down and start with a classic Spring integration application. It's pretty simple. Is that font big enough? Or let me. Oh, it's the wrong one. Text. Okay. Sorry about this. Okay, so this is a very straightforward Spring integration flow. It's not doing very much. We start with a gateway, which is, again, our preferred way of getting messages into the messaging flow, so that your application is not aware of the messaging flow. It just invokes a method on an interface. And we just have two components here. We have the transformer, and it's just doubling up the payload. And then we have a service activator. This is really we're doing an uppercase on the payload. Obviously, that's something that would normally be done with a transformer, but we're just trying to just show a representative flow here. And as you'll see, the service activator has no output channel. So that discussion I was talking about earlier about the reply channel, that tells the framework. So the message starts with a gateway. We have a request, the default request channel is foo. It hits the transformer, it goes to bar, it hits the service activator, and there's no output channel, so the framework says, okay, it's time to send the reply back to the gateway. In Java, we have a simple, we're just getting the application context from that file, and within this, we're just going to send foo, and we're going to print line the result. So pretty simple integration application, and when we run it, sure enough, we will see foo. So we send foo, we said payload plus payload, foo, and then uppercased it, and the reply came back to the gateway. Pretty simple stuff. So the next thing I'm going to show is what you could do with Spring Integration 3.0 and before with annotations. Now, the code's the same in terms of loading up the application context. I didn't show in here actually. The interface that we called was this foo service. So again, for those of you not familiar, the framework builds the implementation of the foo service that we invoke when we do the get bean. So looking at our second example. What I've done in the XML now is said annotation config. I got the same gateway. I got my channels, and then I've defined this bean, which is this XML and Pojo, and then there's my components bean. So again, we can annotate a class as message endpoint, and we can define transformers, input channel, output channel, service activator. Essentially the same functionality, but with the implementation being in Java instead of pure XML. Now, as you can see, we still have to define the bean. Now we can minimize this even more by using component scan, context component scan to find this class, but we still have to have some XML to bootstrap it. We have to use this annotation config. We can even use at configuration with at component scan, but we still need some minimal XML to bootstrap the Spring integration environment. The parsers do things like declare the default error channel, they declare the task execute or the task scheduler, and the various infrastructure beans that have to be created by in order for the integration flow to work. So just to complete the picture here, we have essentially the same application, but with the Pojo transformer and service activator. So that was the state of the art as of Spring Integration 3.0 and before. The annotations were introduced in 2.0, and we really didn't do very much beyond that. But it had those limitations. We still need the XML. So let's take the next giant leap, and what we can now do with Spring Integration 4.0 is no XML at all. So again, we're just booting up the application context. This is new in 4.0. Now remember I said that the framework builds the Pojo, or the implementation of the gateway interface. Now Spring component scan we'll find beans, we'll find objects, we'll find at component, at service, and all those Spring beans, but it won't do anything with an interface because Spring doesn't have any notion of an interface. It's all about beans. So we have a new annotation that you can put on an interface called App Messaging Gateway, and this is the equivalent of that gateway in XML. We have an annotation on our config class called Integration Component Scan, and that specifically looks on the class path for these App Messaging Gateway annotations. So that essentially does the same thing as our XML, this App Gateway, and all the same attributes are available in the annotation. So we can do things like the default reply timeout and stuff like that. So again, we get context assist. So this is we just the integration component scan tells the framework to look for these gateways and create the same implementation that we would use using the XML. The second annotation that's critical is at enable integration. This annotation is used to do what I described that the parsers do: create the default error channel, create the task executor, task schedulers. I keep saying this. Create the task schedulers, and all those sort of the bean post processes and everything that we need to get the integration environment running. So now we have this basic. We're loading up the application context. Obviously, of course, now we're doing annotation config application context, and we're giving it this config class, which I've defined down here. And once again, we have pretty much the same thing. So we have our gateway feeding into a channel called foo. And the channel foo is then consumed by this transformer. And it's a little verbose. We have to write the code now to do the transformation. In XML, we had a nice little expression. In order to do it in Java, we've actually got to write the code. So I got these little helper classes. One that duplicates the payload or concatenates it with itself, and then one that does an uppercase. So we have this Java code, and now the big change in 4.0 is that the at transformer annotation can now be alongside an at bean. So we define a bean that is a transformer. And you can see it returns a type message handler. That, again, is what I mentioned earlier about the tight wiring of the message handlers into the environment. And service activator, same thing. So all of the annotations that previously, if we go back to the previous, before 4.0, those annotations could only appear on methods that were within a message endpoint class. Now they can be applied to actual bean definitions, and that enables us to completely eliminate XML. So now we have no XML, and just to prove it all works, I run this C, no XML, and we get our foo-foo. Now, one could argue, and I probably will, that this is a lot more complicated than this. Than this, right? But some people just don't like XML. That's just the way it is. Now, one slight improvement over this is if we look at using Spring Boot. And we all, as Dave said last night, we all love Spring Boot. And so I have a boot version of this same application, and it's a little easier because now we have we don't have a separate config class. I'm using boot enable auto configuration, which, because Spring integration is on the class path, it will do enable integration. So it automatically sees that this is an integration application. We do need the integration component scan. That doesn't come for free with boot. So again, we find the messaging gateway on a class path. We send the message to channel foo, and all these beans are at the top level within the Java. And again, it's still fairly verbose, but it's XML free. So let's just run that. So I'm running under boot, and you'll see the familiar boot stuff coming up, and we'll again get our foo-foo. So again, there's two flavors of no XML. We have just using pure Spring without any boot, and you have to have a separate configuration class that's annotated appropriately. And then we have this version using boot. So, as I said, to me, it's interesting, and it's good that we can configure an application without using XML for those people who don't like XML. But if that was the end of the story, I don't think it would be very compelling. It's a little clunky, and it's somewhat difficult to visualize what the flow's actually doing. So now let's enter the DSL. And what do we get with the DSL? So again, Spring Boot to bootstrap everything, enable auto configuration to find integration. We've got the gateway once more. And here we have our DSL flow. The general syntax is we're building a flow. The from can be a channel. It can be an inbound message source, and then similarly we do the transform. And then this handle method is sort of the equivalent of the service activator. So any message handler can go in here. And as you can see, we're using Java 8 lambdas, which really makes the syntax succinct. So we have this particular flow does exactly the same as what we've seen before. We send a message to the channel foo, it gets duplicated and upcased. So let's just run that. We're on E. And so we get foo-foo. Okay, now one improvement that we've made with this, as long as you use, well, you have to use Java 8, of course, and if you're using, you don't have to use Java 8 for the DSL, but to get this the nice syntax, you need Java 8. But if you're using Spring Integration 4.1 rather than 4.0, then we have a sort of a further improvement in the syntax, in that the flow itself can be invoked as a lambda. So we can actually say FF, and then we no longer need this. Let me take a step back. So this integration flows factory class is really building. It really creates a flow builder. So we're building the flow by adding all these elements as we go along, and then obviously we have to finish the build, right? And that's what that get method does at the end, is it actually returns the integration flow object that we then work on. But if we're using Spring Integration 4.1, because of some work we've done with the way that channels are initialized, we can now use a lambda to do this, and we no longer need the get in this case. So again, a nice little tweak to the syntax has made that even more succinct, and hopefully I run this, I won't be embarrassed. But what did I do? Yes. Oh, good. I'm glad that I did that. So you'll notice that I actually, before we had integration flows from foo. Well, we don't have a foo class here now, so we actually create an implied channel called flow input. So the bean name is flow for the flow, and then if you use this syntax, then you're going to get a channel called flow input. So let's run it this time. Yep. Oh, the other one's still running. Let me stop the other instance. Foo-foo. Okay. Now, it's all very interesting, but it's kind of a simple application. So let's take a step further, and hopefully this will show some of the power of the DSL, particularly with you doing it with an IDE and getting code completion. What I'd like to do now is take this application that creates this foo-foo message. I'd still like to get the reply, but I want to also email it. So what I'm going to do is basically go to the next sample, which is the F version, and start adding to this flow. So we have the same as what we just did. We have our default request channel is foo input. Let me make this full screen. And what I want to do now is actually, so as I said, I still want to return the result to my gateway, but I want to email it. So first thing I'm going to do is I'm going to use a recipient list router, and you can see we've got content assist here. So I'm going to say route to recipients, and I'm going to use lambdas to populate my recipients. So I'm just going to have a recipient, and see now it's just channel name and an expression that evaluates whether this recipient receives the message. I'm going to call it bridge to nowhere, and I'll explain what that is shortly. And I'm just going to say true, right? The expression is going to be true. I always want to send it to this recipient. And I'm going to add another recipient. What did I call it? SMTP. And let me just, okay, so all I've done now, and as you can see, we've got code completion, and we're now, instead of just, because previously the handle had no output channel, it just returned to the gateway. But now we want to, I'm going to send it to a bridge to nowhere, and I'll explain what that is, and then also to SMTP. So the bridge to nowhere, this is a fairly common pattern where you want to do something like this. You want to send a message to multiple places and also send the reply. So we have this notion of a bridge. So I'm going to create a bean. Oops. A message channel. I'm just going to call it bridge to nowhere. Spell it. Direct channel. It's too early. You may want to change the string of bridge nowhere. Oh, sorry. Thank you. Otherwise, it's going to blow up. All right. Now. One of the new annotations that we have in Spring Integration 4 is a bridge to. So if you in XML terms, if you were bridging from channel A to channel B, you would have you can either annotate channel A and bridge it to channel B, in which case you would put the value is the channel that you want to bridge to. But in this case, I don't want it. This is just a technique. We're going to send a message to a bridge, and again, using the technique that I described earlier about the reply channel in the header. There's no output channel on the bridge, so the reply goes back to the inbound gateway. So that's our bridge to nowhere. And now I want to create the mail outbound channel adapter. So we're going to create an integration flow. What did I call it? SM. Oh, I should also create my SMTP channel. So I'm going to create my flow, my mail outbound channel adapter. So I'm going to return integration flows from SMTP. Now, one thing we like to do, or we need to do when we send to mail, for those of you that are used to using mail in XML, we have a mail header enricher, which adds things like the to and the from and the subject. So we're using the DSL to SMTP channel. Again, code completion. We get in the ability to, we're going to enrich headers now. So we have this notion, we have a bunch of factory classes, and in the case of mail, we have the mail headers builder, and just using the, I'm going to say subject. 2014. .2, and I have SpringOne at Gmail. Oop. And we'll send it from the same account. So that's now added headers to, so we've just basically done an inline header enrichment within the flow. And now we want to handle that message. And again, we use the mail factory to get us an outbound channel adapter. SMTP, gmail.com. The port is 465. Protocol SMTPS. Credentials. Now, I've previously built this using Boot's properties configuration support. I have this Gmail properties class, which is populated from the application YAML, Boot's application YAML. So I've externalized the properties into this class, and in our application, we enable configuration properties using the Gmail properties class, and we auto wire in an instance of Gmail properties. Now, if we take a look at application YAML, the one in the project's obviously empty. This has the Twitter stuff in it because, as I said, this project builds on top of the demonstration from the spring where we did a Twitter search gateway call. So this is our application YAML, and of course I have a real one on my class path that has values populated for the Gmail user and password. So we have this Gmail properties class, and that's going to be populated by boot with the credentials. So we can just use gmail.getUser, gmail.getPassword. So that sets up our credentials. Anything else? Oh yeah, this is kind of nice too. So we have Java Mail properties, and we have a properties builder in here. So again, using a lambda, we can set some properties. So we can say put mail debug. I'm going to set it to false because I don't want it to be verbose, but you can see the point here that we can just. So if you need to enhance the Java Mail properties in any way, you can just use this builder in this way. Okay, let me see. Now, what's that in here? Oh, it's just a mark on my screen. I thought there was a character in there. So we built our outbound adapter. We added the port, the protocol credentials. And the next thing we can do is outbound adapters. Again, for those of you familiar with Spring integration, outbound adapters are wrapped in endpoints. So the endpoint has lifecycle capabilities. So for example, so the second parameter to this handle is actually a reference to the endpoint. So for properties like auto startup, again, we're getting code completion. We can set auto startup true, which is the default, and we can set the ID is SMTP out, and then of course we do the get, and that's going to return our mail adapter. So now our flow starts with the channel. We add a header enricher to do everything we need to do. Let me just make sure I've typed everything right. That's SpringOne at Gmail. And then we built the outbound adapter with all of its properties.
Gary,
Yes.
check your bridge. There's a case.
On the bridge. Bridge to nowhere. Oh, thank you. Yeah. Thank you. All right. So what do we have? So now if we run it, we should get our foo-foo back in the console, and we should get an email sent to Gmail. So let's run F. Fingers crossed, no typos. So foo-foo gave us back, that came back from the bridge to nowhere. We set to a recipient list router. We sent one copy to the bridge, and we sent one copy to the mail outbound adapter. And hopefully, when I bring up my mail, there we go, 9:15. We have this message, foo-foo. So we sent the message to email. So hopefully that's a good illustration of how the DSL makes it a lot easier to build some of these components than using XML. So we're not entirely done. Why that's so slow. Let me run it again, so I just put another email in there. I didn't really want to delete that. The source code for this project is currently in my copy of the repo. There's 2 commits. There's the first 5 and then there's the end state after the thing. I'm gonna push this to master probably later today or tomorrow. It's right now I took the web the Spring Boot web starter out, which is needed for the Twitter example. So it doesn't. It's not quite. I just have to do a bit of polishing before I push it to master. But this is in the samples repo. Some of the other talks have got there's a SpringOne repo on GitHub that they're putting their stuff. But because this built on top of the webinar from the Spring, I decided to put this right in the sample and commit it there. Any more questions before I move on? Just for the sake of the program, the question was is this code in GitHub, and it is. Yes, sir.
Yeah, I've seen in Spring where it'll use, I guess it's using the XML to kind of show a visual flow.
Mm-hmm.
Do you use all that?
Yes. Simple answer is yes. I mean, the tooling typically is always a little bit behind. Now, whether we'll ever be able to... See, it's very difficult when you're wiring flows in Java. It's a little more difficult for tooling to interpret what's going on. But I'm talking to the tooling guys, and we'll see what can be done. But hopefully, as I said, when it's built in Java like this, it's a little easier to see than a whole bunch of XML. What the flow looks like. But yeah, pretty pictures are always nice, right? The question was about tooling. Does the tooling support the DSL or even configuration? So the last thing I'm going to cover is let's now consume those emails using an IMAP Idle inbound channel adapter. So this is I let it. So when you do look at the repo, you'll see under this annotations and DSL with the Twitter samples that we ran in the webinar, and then under SpringOne, I've got these A, B, C, D, E, F, G packages, which are each of these progressions that we've been going through today. So the final one is this G IMAP, and so what we're going to do is basically build an inbound IMAP Idle channel adapter. So again, we start with the integration flows factory. We're going to do from, but this time instead of doing from a channel, we're actually going to do from an inbound adapter. So again, we're going to use the mail factory, and as you can see, we have the IMAP Idle adapter is the factory method to start building our. Let me put the get there, and then start that in the next line. Okay, so let's start configuring up our IMAP Idle adapter. Well, first thing we need is a URL for our IMAP, and Gmail requires SSL, so we're IMAPs colon. We need to add our credentials, so I'm going to say Gmail. Get user. Now, because the user for the general syntax for an IMAP URL is IMAP user at host, and then the host port, and then the actual folder that you want to open. Well, Gmail's credentials, or when you sign into Gmail, it actually has Gmail at. You have username at Gmail is your credentials. So we have to escape the @ sign that's in the that's in there. So I'm just going to do a replace of the @. I'm going to escape it with the hex version. So that's just going to take si springone@gmail.com and change it and just insert that. that at 4.0. So then we need the, I think we need the, oh, okay, so then we need password, yeah. So username, colon, password. So I get Gmail. Again, we've got this Gmail is that same, the same property that we loaded before. So we've got our user, colon, password, and now we're going to do the at Gmail, at imap.gmail.com on port 993, and we're going to load up the inbox folder. So that's our, oops, I need a plus. So that's constructed our basic IMAP adapter with the URL that we're going to go after. Now, I mentioned before with outbound endpoints, if we go back to that F example, I had this second parameter to the handle method to reference the endpoint. So things like lifecycle, auto startup, the ID and stuff like that are actually attributes of the endpoint. In the case of inbound adapters, particularly inbound adapters that aren't polled, that actually produce messages on their own right, which is what the IMAP Idle adapter does, we'd have the ID directly on the so that's why we have the ID attribute is right there. Let's see, what else shall I do? Again, yeah, so things like auto startup. Again, all this code completion is pretty cool stuff. Again, Java mail properties. We can do the properties builder stuff just like we did before. P.put mail.debug. And okay, actually I don't want two, I want false. It's too verbose. Okay, so we've built our inbound adapter, our IMAP idle. It's just going to basically sit there and poll the, well, not poll, but using the IMAP protocol idle mechanism to fetch a message. Now, when a message is fetched, the mail adapters currently don't do anything in terms of transforming the MIME message to any kind of Spring integration headers or anything. So what I'm going to do in here is I'm just going to add another header enricher. So the message that comes out of the IMAP adapter, I'm actually going to populate some headers. And again, code completion. We're going to use header expressions. I'm going to build a bunch of header expressions, and expressions. Got the wrong one. And again, we're going to use a lambda to create a builder for this. So let's see, what did I do? I'm just going to, okay, so I'm just going to do put, oops, it is subject, let me just import. Not sure why. And I'm just going to use an expression to get the subject from the payload, because the payload of an inbound mail adapter is a MIME message. So MIME message has this subject object, and I'm going to put mail headers, what did I do? From. And this case, the my message has you get an array of email address of internet addresses. So I'm just going to say from 0. I'm just going to get the first instance, and I'm just going to do a toString on it because I don't want to. So mail headers payload from toString, and we need one more, and we're done. So again, we built the IMAP Idle adapter, set some Java properties on it, and then added a header enricher to just pull out information from the subject, from the subject and the from. So again, let's make sure I got everything right and run that one. Now this particular one, this application sits in the the joys of live demo. What did I do? No output channel. Oh, I didn't do anything with it. I created the message and didn't do anything. So of course it said, well, what do you want me to? Where do you want me to send this? So of course we have to. I missed a couple of steps here. I want to transform it. Again, just using an expression. Again, my message has payload content, and all I'm going to do is sys out the Yep. Multiple instances running. Okay. And hopefully we will see the message retrieved from IMAP in. No. What did I do? Maybe I got some credentials wrong or something. Oh, it's because I looked at that message. All right, let me just send a new mail. Okay, you can see it did come. Let me just turn that back off to turn the debug back off again, and then hopefully we will. Oh, the reason it didn't work was because I'd already fetched the mail when it crashed, when I didn't have the when I didn't have the output. So let me run the IMAP again, and we should just see the message. There we go. So payload foo-foo, headers, mail from, the ID, and so that the headers were enriched, the mail subject, blah blah blah. And of course we can just send another mail. And so we sent it, and it should auto switch to the other window, and there we go. So what do you think? Well, that's all I had in terms of demo. So let's just go back and finish up some slides, and then we can open it up for any more Q&A. So I talked about the 3.0 changes, the 4.0 changes, and we've looked at the DSL. As I say, the DSL, we're keeping it as an extension for now because it's a little more dynamic, and we're adding adapters, and it's going to have a faster release cadence than Spring Integration itself. We will release 1.0 in late October, early November, and then we'll have multiple follow-ups. When it catches up with Spring Integration, then we'll roll it into integration proper, probably in the 4.2 time frame, I'm guessing. In the meantime, we do have some changes in 4.1. We did release a milestone last week. And it's planned to be released at the end of October, early November. To get that extra syntax, that extra sugary syntax with the using lambdas for integration flows, you need to use Spring Integration 4.1 because, as I said, we've changed the way that channels are initialized, and so it makes it a little easier to do that. Milestone released. It does require Spring Framework 4.1. We've added a reactor promise and listenable future return types to gateways. Previously, we've been looking at gateways. We've just been doing send and response. We have an async gateway where if you define your return type of the gateway method as a future, then you can go away and you can send off your request to the gateway, do more work, and then do a get on the future to get for the response. It's still a blocking return with both reactor and with the listenable future. Listenable future was added to Spring in Framework 4.0, and we've now added that as a capability to the framework. So you can now, if I pull up my right browser, you can now go completely async. So make that a little bigger. So completely asynchronously now, you can invoke the gateway with a listenable future. And previously, if you wanted to send a message to a gateway and then later on have the reply come back completely asynchronously, you had to play some tricks. You had to have a void return on the gateway and use an inbound channel adapter, an outbound channel adapter to send the reply back into your same POJO. So now with a listenable future, you get a completely asynchronous story. So we invoke the gateway, we're sending some data to it, and the result we get back is a listenable future, and now we get an async callback. When that result comes back from the flow, it'll just invoke either on success or on failure based on what happens. So that, I think that's a nice little feature that we've added there. Let's go back. So reactor as well. WebSocket adapters, it's still very much in the sort of experimental mode, but building on top of Spring Framework's WebSocket, we now have inbound and outbound channel adapters for WebSockets. Anybody heard of Boon for JSON serialization? This was announced a few months ago. It's a Groovy-based JSON object mapper that has got some significant performance improvements over Jackson. So we've added so if you're using JSON transformers, if we find Boon on the class path, then we'll use it and still continue to support Jackson, of course. Some improvements to MQTT adapters. We got some feedback that we'd like more of an async capability with MQTT, where we can send messages and not wait for them to be confirmed to be in the broker. And Glenn has a talk on Wednesday about the MQTT, working with the MQTT adapters, and he'll be talking about some of that. We've added the capability to append to remote file. Again, this was a community request, so now you can basically use the SFTP append mechanism, or you can append to a remote file rather than creating a new file each time. A second thing that we did in there, which I didn't mention on the slide, is under the skins now, the outbound FTP and SFTP adapters and gateways use implementations of a remote file template. And remote file template is similar to the Spring X template, JDBC template, JMS template. It sort of hides a lot of the complexities of the underlying client that we're using. But the remote file template now does give you an execute method, so it gives you the ability to get to that underlying client if you want to do any specialized work. And the other big thing is this splitter iterator. Previously, if you had a large collection, whenever we split a message into multiple parts, you had to basically have the whole collection in memory. So we would basically bust apart the collection. With the iterator, the splitter object, the class that we invoke with the splitter, can now return an iterator. So that can basically feed the split pieces in more of a streaming fashion, rather than having to have the whole thing in memory. It's a little bit off topic, but my other project is Spring AMQP. For those of you, anybody here using AMQP Rabbit and Spring AMQP? Okay. So a really nice feature. Stefan is talking later today about JMS annotations in core Spring, in Spring JMS. Well, he's also added the implementation to Spring AMQP. Now, this is we put the first milestone out on Friday, and now you can. I mean, he even tweeted a tweetable Rabbit listener. That's just Rabbit listener, and then the name of the method name and a little bit of code to do with that. So and it can be request reply. So if you basically have a POJO that returns a reply, the Rabbit infrastructure will be built for you to send the reply back to the caller. Some fairly minor changes. The SSL was always a bit of a pain because the SSL, the underlying Rabbit connection factory is not Spring friendly. You have to set SSL set SSL up. So we added a factory bean just to make it a little easier to build SSL if you want to use SSL. Again, docs there. So that's all I have for today. I'll open it up to questions if there are any. Yes, sir.
Make good use of Java 8 lambdas. If I'm working in Groovy, will closures work just as well?
I don't know. I'm not a Groovy person. I don't know if Dave.
I'm not sure what I know. If you get the Groovy Grails version, there's a lot of features in there.
Yeah. The question was whether Groovy closures can be used instead of Java lambdas. I'm not a Groovy person, so I can't answer that. There is a it's a little it needs some work, but there is a Groovy DSL that Davey worked on some time ago that needs to be, if there's interest in that, we can revitalize that project. But although I showed all the DSL, it definitely benefits from Java 8. If you're using Java 7, then a lot of that stuff where we're using builders, you end up having to do add interfaces in the middle of the flow, which makes it a little less pretty. So I definitely, if you can, I would definitely look at using Java 8. Any more questions? Yes, sir. Go into different? So the question was, do we have example about going to different channels? Well, I did show in the example here. I used the recipient list router. There we go. What was that? And it was in F. So we added this recipient list router. Or in DSL terms, it's a verb. So we would say route to recipients. So you would just say route. So in this case. So we have a simple route, which is to add a router to here, but these are expressions. So you can say, send this to the bridge to nowhere if payload foo equals bar, right? So these are conditional expressions on these recipient list routers. So you can decide where you want to send it using a recipient list router. You can use a regular router with expressions as well. So anything that's available in XML is available through these techniques. Any more questions? Is anybody going to consider using the DSL or play with it? That's good. All right, well, thank you very much.